Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Up until now, when we've worked with functions, the process has been straightforward. You plug in an x value, and then you calculate the corresponding y value. But in calculus, we're often interested in a different kind of question. Not what happens at a point, but what happens near a point. So to see why this matters, let's start with a simple rational function. By the way, if you haven't subscribed to our channel yet, make sure you do that first so you don't miss out on weekly new content. Now let's take a look at our function f of x. In the denominator, we have x minus 3. So that tells us the domain of f is going to be x cannot equal to 3 because we cannot divide it by 0. Now let's go ahead and fill out this following table. But to make our lives easier, let's go ahead and rewrite f of x. So we have f of x is equal to, and we're going to factor our numerator. So this is going to be x minus 3 times x plus 1 divided by x minus 3. So notice how we have the factor x minus 3 on top and on the bottom. So therefore we can cancel it, and this is equal to x plus 1. Of course, this is given that x is not equal to 3, which is our domain. And now we can go ahead and use this simplified version because none of our points are 3. So we would get, if x is equal to 2, f of x would be 2 plus 1, so that'll be 3. When x is equal to 4, this is going to be 4 plus 1, so that'll be 5. And then when x is 2.9, this is going to be 3.9. And then this is going to be 3.99. And then on the other side, we have 3.1. So f of 3.1 would be 4.1. And this would be 4.01. So now the question is, what value will y approach as our x approaches 3? So notice how we're saying that it's approaching 3. It's not equal to 3 because 3 is not in our domain. And we can see that if our x value is, say, 2.99999, then the value of y is going to be 3.99999. So our natural guess here would be that y is going to approach 4 as x approaches 3. So this is all a little bit hand-wavy, but this is the idea behind the limit of a function. Let's go ahead and take a look at the actual definitions. We say the limit of f of x as x approaches a equals L. And in notation form, it is written like this. So this is limit of f of x as x approaches a is equal to L. So this is essentially saying that this y value here, which is f of x, is approaching L as our x value is approaching a. Meaning we're taking x as close to a as we'd like, but it is not equal to a. Now, before we hop into an example, we're going to take a look at one additional definition, which is the left hand and the right hand limits. They're basically identical. The only difference is that for the right hand limit, we have a little plus sign here, and then for the left hand limit, we have a little minus sign. So for example, we will say the right-hand limit of f of x as x approaches a equals L, and this is how we would write it. So the little plus sign just means that we're coming from the positive side, which is the right side. And then similarly for the left-hand side, we write a little minus sign to indicate that we're approaching from the negative side, which is the left-hand side. The difference between these one-sided limit and this overall limit is that for these one-sided limit, we only care about the side that we're approaching from, whereas this overall limit, we need to look at both sides. And this will be made clear in the following example. So for this example, we have a piecewise function. Let's first draw the graph of this piecewise function. So we have 1, 2, 3, 4. This is -1, -2, -3. So now for x less than 1, our function f of x takes on the form x squared plus 2. So that means it's going to have a y-intercept of 2, and it's a parabola looking like this. And then we just need to go to x is equal to 1, and then we're going to put a hollow dot there since the domain is x is strictly less than 1. Now, the next piece is when x is equal to 1. So when x is equal to 1, our function f of x is equal to 3. So that is actually exactly where that hollow dot is, so we're going to go ahead and fill it in. And then for x is greater than 1, our function f of x takes on the form 5 minus x. So that means we're going to have a hollow dot at y is equal to 4. And then we're going to have a linear line with a slope of -1. So it'll look something like this. Okay, now let's take a look at what limits we want to look at. So the first one is we want to find the limit of our function f of x as x approaches 0. And notice that this one is an overall limit, so means we need to take a look from the left-hand side and the right-hand side. So imagine you are going along the curve of f of x. And as you're approaching 0 from the left-hand side, we can see that we're approaching a y value of 2. And then as we approach x is equal to 0 from the right-hand side, we are also approaching the value y is equal to 2. So therefore, the limit of f of x as x approaches 0 is going to be equal to 2. Now let's take a look at the next one. We're looking for the limit of f of x as x approaches 1 from the left-hand side. So that's what this little -1 means. So if we're approaching 1 from the left-hand side, that means we're following along the curve and we're approaching it from the left-hand side. So we can see that as we get closer and closer and closer, the y value is going to approach 3. And notice how we only care about the left-hand side. We're not approaching from the right-hand side because this is a one-sided limit. So therefore, the answer to this one is going to be equal to 3. And now for the next one, we're going to approach 1 from the positive side, which means we're going to approach 1 from, let's say, 1.5, 1.2, 1.1, 1.01, and so on. So even though this is a hollow dot at x is equal to 1, we don't really care because we're not actually at 1. We're just approaching really close. So without knowing what the graph is like, pretend like you're just on this line, you're a little ant and you're traveling along this line. As you get closer and closer to x is equal to 1, the y value is going to get closer and closer to 4. So therefore, the right side limit is going to be equal to 4. Now part D, this is actually asking for the value of f of 1, meaning what is the actual y value of the function when x is equal to 1. So in that case, we need to actually plug in our 1. So looking at our piecewise function, when x is equal to 1, f of x is equal to 3. So f of 1 is equal to 3. And now finally, we're looking for the limit of f of x as x approaches 1. So this is an overall limit, which means we need to take a look at the left-hand side and the right-hand side. So earlier, we looked at both of them. We saw how the limit of f of x as we approach 1 from the left-hand side is equal to 3, but the limit of f of x as we approach from the right-hand side is equal to 4. So because they're different, that means the overall limit does not exist. So the limit as x approaches 1 for a function f of x does not exist. So now let's do a recap of what we covered in this video. So a limit describes the value that a function approaches as the input gets closer and closer to a specific number. And we write it like this. And the important thing to note here is that we're not saying that x is equal to a. Instead, we're describing the behavior of the function near a. So the value of a limit depends on the trend of the function and not whether or not the function is actually defined at that point. We looked at one-sided limits, which allow us to examine what happens as we approach a point either from the left-hand side or from the right-hand side. And we learned that an overall limit exists if and only if both one-sided limits exist and are equal. So in notation form, that would be limit as x approaches a of our function f of x is equal to L if and only if the limit as x approaches a from the positive side of f of x is equal to the limit as x approaches a from the negative side for our function f of x, and both of them are equal to L. And finally, the value of f of a can be completely different from the limit, or it may not even exist at all, and that does not affect whether or not the limit exists. And now, it is your turn to give this a try. Sketch this piecewise function and determine the following limits. Make sure to leave your answer in the comments below, and let us know if you'd like to see more content on limits in the future.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.